Now we discuss about the different hash functions. So the very first hash function is the division method. In the division method, we consider the hash function to be a mathematical formula which should look something like this equation: h of x equal to x mod m. What is x? X is the data value, right? H is the hash function. H is the hash function, and m is a certain number, right? This is a certain number which we will discuss in detail about when we actually go in depth about this method, right? This mod is basically a modular division. That means you obtain the remainder out of this, right? If I want to store the x, which is the data value, in the hash table, then I divide x with m and then obtain the remainder value. The remainder value is the index value where I have to store the x in the hash table, right? So I will take a very simple example about this concept. I will take, say for example, the value of x is 13 and the value of m is 11, right? So h of 13 will then be equals to 13 mod 11. So obviously the result that I'm going to get is 2. That means in a hash table which starts with 0 index, then 1, 2, then the 13 will be placed in the second index. This is the index value, right? This is the index value. So over here, the data value and the key value both are same. So now what is this m? This m is a certain kind of number which has to be selected very carefully. Why? Because this will help us to actually evenly distribute the keys among in the entire hash table, right? So if I consider taking m to be an even value, then all the x which are even value will obviously get a remainder as even, right? So for example, if I take if I take the if I take the value of m to be as 10, and if I take the x value to be say 60, then I will get 0, right? Then if I take the value as 66, then 6 again, which is an even value. So every time if the x is an even value, since m is also even, the value that is obtained from the remainder will also give you an even number. Now if I say that if m is an even value and x is not an even value, this is an odd value. X is an odd value, then we get odd remainder value every time. Like if m is 10, we have considered 10 as to be m, and if the x is an odd value, say 67, then it will be obtained, the remainder will be an odd value again. Say again, let's say 53, which is the odd value. So 553, this is the odd value. So every time when m is even and x is even, then we get a remainder which is again an even number. And if m is even and x is odd number, then we get a remainder value which is an odd value. So so this will not create a problem as long as the number of even value data, number of data value which are even and the number of data value which are odd are equiprobable, right? But if they are not equiprobable, like if even values occur more than the odd values, then the key values, then the data values will not be distributed evenly in the entire hashing table, So obviously the third property that we have discussed in properties of good hash function will get then violated. So in order to select the value of m, what we do is that we consider m to be a prime number, right? We take m to be a prime number. This is popularly followed, and then we obtain the remainder value which gives the index to the corresponding hash table, and we actually store the data value into the corresponding hash table. Now we come to the next method, which is multiplication method. In this method, what we do is that we choose a constant a which has to lie between 0 and 1. Obviously a can be a floating point value, Then what we do is that we multiply the key k by a, right? So what we do is that the key k value, which has to be converted to an integer value, right? That key k value is multiplied by a. Now what we do is that the multiplied result that we obtain, from that result we are going to extract the fractional part and then multiply it with the size of the hash table, which is m. So in order to understand this particular concept of this algorithm, we take a simple example. The key k value that we want to store is 1, 2, 3, 4, 5, and this is also the data value as well as the key value. So now what we do is that we have to basically obtain the integer value, which will be the index of the hash table where 1, 2, 3, 4, 5 will be stored, right? 12,345 will be stored, right? So now what we do is that we first multiply 12,345 with a value of a. This a value is coming from this particular calculation, root 5 minus 1 whole divided by 2. Now you may question that what is this value and how is it obtained? This value is given by Nuth. Right, so this value is given by Nuth. You can take any value you want. This is not necessary that you have to take always this value. You can take any value you want, but Nuth basically have proposed this value with some calculations and found out that this particular value is basically yielding a good value of a, so that the keys are evenly distributed in the hash table. So it's not a case that you cannot choose other than the value that I've mentioned on the board. You can choose any value of a that you want, right? So I have used the value of the value suggested by Nuth, and I have multiplied the value of a, which is this. This is a, right? This is a. I multiplied value a with value k, right? So this is k. So I have to after we multiply these two results, we obtain a product of something like this, 7,629.617385. Now to obtain the fractional part, which is this part, this is the fractional part, right? So I have to obtain the fractional part. In order to obtain the fractional part, I have to divide the entire product by 1 and obtain the remainder result, right? So in order to obtain the remainder result, so if I obtain the remainder result, I will get the fractional part extracted, and the fractional part is then multiplied with the m, which is also the hash table size, which is 1000 over here. And then after we multiply 1000, we get 617.385. So from this, if we take the floor value, or if we take only the integer value out of this, then the value is 617, which is the indexed, which is the index value where we actually going to store 12,340. Now we come to the third hashing function, which is the folding method. Now in folding method, if the key k is also the data value in our example, and we have to store the data value in a hash table, right? Then we have to first map the key k to an integer value, to a basically a feasible integer value, right? So obviously, if I want to store the key k, then what I do is that I will chop, or I will break this particular k into several pieces, right? Such that each piece contain equal number of digits except the last part, right? So it may or may not contain equal number of pieces only for the last part, but for the remaining, that should contain equal number of digits. Now what we do is that we add up all the pieces together. Now the result that we obtain, say it is x, and the hash table size is m1 in our case, right? This is the hash table size. This is m1. Now, if x is greater than m1, what happens? If x is greater than m1, some books say that we have to again break up this x, or we again have to chop x to x1, x2, xn. Again, we have to add all the elements and then obtain another value y. So this process of chopping and adding will continue until and unless the added result that we obtain is not less than m1. If it is less than m1, we actually store that key k into the index value that we obtain after adding all the chopped pieces, right? So this is a method. So another method is, if x is greater than m1, then another method is we actually then apply division method, right? Then what we do is that we actually divide x with the hash table size and obtain the remainder. Right? The remainder that we obtain is the index location where we are going to store the key k. So it depends which method are you going to follow. The folding method basically have several different variations. Like in this chopping, also there is a kind of variation. If I chop key k as k1 plus k2, k3, k4 dot kn. Some methods or some books show that except for the boundary values k1 and kn, except for k1 and kn, all the intermediate chopped pieces are reversed, and then all the chopped pieces are then added together. Right? So the adding and chopping has several different kinds of variations, right? So what they do is that they chop the key k into several different pieces, and then except for the boundary chopped pieces like k1 and kn in this example, all the remaining chopped pieces will be reversed first, and then all the chopped pieces are added together to obtain a value x. Again, if x is greater than m1, again you can repeat the same process of chopping, or you will basically apply division method, whatever you want. Another method of chopping is you are chopping k as k1, k2, k3 dot kn. Right? So in this chopping method, what we do is that instead of in the previous method we were actually reversing the intermediate chopped pieces except for the boundary chopped pieces. Here we actually reverse the first and the last chopped pieces, and then add all the chopped pieces together to obtain the added result as x. Again, if x is greater than m1, either we again follow this method to that is, we will chop this x again, and then we will reverse the boundary chopped pieces and add all the chopped pieces together until and unless it is less than m1, or we are going to apply the division method. Whatever be the case, whatever method you want to apply, you can apply. You can apply as you want, right? So there is no restriction on applying that particular thing. Okay, now we again come to the last hash function, which is a Midsquare method hash function. Here what we do is that the key k value, which we actually want to map to an integer value, is first multiplied with itself. That means we are trying to find the square of that particular number. So if the key is multiplied by itself, that is its k square, then after you multiply, you extract the middle r digits from the obtained product, and the extracted value that is obtained is the index value where you actually want to place the data value. Here again, the data value and the key value both are same in our example, right? So if I say that h of 1, 2, 3, 4, which is the key value as well as the data value, then 1, 2, 3, 4, that is 12,234, which if multiplied by itself will give you a result of 15,22,756. Either you will start extracting the middle digits from the right, or you are going to traverse it from the left. So if I do it from right, then I will take 27 as the number, or if I just move from the left, then I will take 22. So whatever number you take or whatever thing you take, that is the index value where you have to actually store 1234 into the hash table. So these were the different hash functions which are popularly used, and we will be using in our example as well. So obviously you can also create different hash functions, but whatever hash function you create should not violate the properties of hash function that are already discussed.